Hi, I'm Phil Porras, and this is a demonstration of an OpenFlow security controller using FortNOX. In this demonstration, we're going to illustrate an OpenFlow-empowered approach to automatically isolating malware-infected hosts from production networks. In this demo, we'll be using an HP ProCurve E6600 OpenFlow-enabled network switch. It will be managing a production network whose host can communicate with the internet through the switch. The switch is managed by our OpenFlow security controller, which is implemented using the FortNOX security kernel. And we'll be using Bot Hunter, augmented with our FortNOX threat response agent, to patrol the network for remote attacks and malware infections. As we'll see in the demo, the web proxy notifier is activated when a host is quarantined. We will use this proxy to pass a notification page back to the infected host owner. Here is how that topology maps to our live demo display. The left full panel shows the desktop of a Windows 7 host operating within our production network. The upper right panel shows Bot Hunter's threat responder console in blue, which is currently monitoring the production network. To the bottom right, the white panel shows our FortNOX console. I'm now going to demonstrate a classic self-inflicted malware infection. The goal is to use Bot Hunter to diagnose the infection live as it unfolds, followed by the threat responder, which will then direct FortNOX to initiate a quarantine procedure to protect the victim and our production network. First, let's start our OpenFlow security controller and allow it to initialize the switch. Now, about the infection. Let's assume that, like all internet users, I'm constantly enticed to click on email attachments or web links, or attach my machine to questionable USB devices or Wi-Fi hotspots. There are a myriad of ways malware infections can propagate, even within networks with strict network boundary controls. Unfortunately for me, today I've gotten enticed to click on a friend's attachment with an apparent greeting card of some sort. Well, it's not my birthday today, but it certainly is a nice-looking greeting card. As it turns out, this greeting card came with a gift. When it launched, the app fetched, stored, and execed a rootkit that it retrieved from my friend's machine. Once embedded, it tried to phone home to a fairly notorious Ukrainian botnet control center. It's also begun an outbound attack spree to seek out other local machines that it can propagate to. Fortunately, for infection profiles of this nature, I've pre-programmed Bot Hunter's threat responder to automatically issue a quarantine directive to FortNOX. Here's how that works. Once my host became infected, Bot Hunter observed it reaching out to a botnet control center, which it could detect based on to who and what was being communicated. It also observes a continual stream of malware-focused port scans from my host performed across the production network and possibly out to the internet as well. Bot Hunter issues an infection profile with fairly detailed forensics and a high enough score to trigger the actuator to initiate a quarantine of my host. The quarantine directive is asserted to FortNOX, which translates the request into a set of OpenFlow rules that it pushes to the switch. In effect, my local host is cut off from any and all communications over the network, with the exception that all the DNS and web traffic that my host initiates is redirected by the switch into my notifier proxy. There, the proxy will respond to all web surfing requests with a notification page that this host is quarantined and I should go see my system administrator to determine what steps we need to take to recover my host. I'll illustrate that result here. I'm going to launch my browser and attempt to connect to a random website. No matter what site request I make, my web browser will be directed into the quarantine notification page. Thanks for watching our OpenFlow-enabled malware quarantine demo. For more information about FortNOX, please visit www.openflowsec.org.